All right, so in this next example here, what we have is inside the function does not look very nice, right? So we weren't going to want to rewrite this, and there's a couple different ways we can rewrite this. First of all, we can just take this as a negative x over 2 minus pi, and we can rewrite this as fractions. So basically writing this as a negative 1/2 x minus pi. And that's going to help us to be able to write this again in our form of b times x minus c. So we're going to have to factor out this negative 1/2. And we factor out the negative 1/2, basically think about that as like dividing out negative 1/2 from the negative 1/2 x as well as from negative pi. So when I factor out a negative 1/2, I'm just going to be left with a positive x and then plus 2 pi. So what that tells me is my phase shift here is going to be 2 units to the left. Now that might not be as obvious using this method, or you might not like this method. So we can also go with understanding the transformations from our initial period. And so again, to work on that method, basically all we're going to do is take negative x divided by 2 minus pi and set it to either our initial period end or beginning, which is at negative pi halves or pi halves. And I'm going to choose the end, which is at pi halves. So to go ahead and solve this method, I'm basically just going to solve for x. So I'll add a pi to both sides. And then I have a negative x over 2 is equal to pi halves. Now I'm going to rewrite pi as 2 pi over 2 so I can quickly add the fractions. Therefore, that's going to give me a negative x over 2 is equal to 3 pi over 2. Now these 2's can go ahead and divide out, or you can multiply by a negative 2 on both sides. And what you would get is x is going to equal a negative 3 pi. Now again, that's telling us where the asymptote is, right? That's going to be telling us where this where the end period is of our, or one of our asymptotes doesn't occur. Now let's go and take a look at finding the rest of the information, and then what I'll do is I'll go to the graph to kind of like further make this point. As far as my phase shift goes, this is what we talked about. The easiest thing to do is be able to factor this out so we can see that the graph is going left too. We also see that there is a reflection about the y-axis, so we can say reflect the y-axis. All right. And then our period. And then our period is just going to be pi now divided by 1/2, which is just equal to 2 pi. So let's go and take a look at this graph. Let's identify the asymptotes here. So the asymptotes is going to be where this initial period, so now the new asymptote is at x is equal to a negative 3 pi, and then plus my new period, n. So you can see from this initial period, or if we were going to have n is equal to 1, you can see that we have asymptotes at negative 3 pi and at negative pi. But let's go and take a look at the graph so we can kind of drive this home here. I think I already had this one. Okay, here it is. All right, so let's go ahead and draw in the graph asymptotes because Desmos is not going to give us that. So let's do negative pi. And then I said x equals a negative 3 pi. So you can see here, let's change these both to red. Okay. So you can see from our original period, right, which would have been at like negative pi halves to pi halves, you can see now here is our initial period, because again we had reflected about the y-axis and then this graph got shifted over. You can also see that the period here from negative 3 pi to negative pi, that's going to be a period of 2 pi, which is again something that we considered. Now obviously this graph repeats itself, but for the sake of just kind of sketching the graph, I am going to use just kind of represent the initial period. So I'll just say like here's negative pi, here's negative 3 pi, and those are my asymptotes. And then since it's got reflected about the y-axis, the graph is going to fall to the right and rise to the left. So that's what the graph looks like, which again, you can verify with what I just wrote. All right, so on this next one, now we have a vertical compression. Again, it's not affecting the amplitude because there is no amplitude here. But I can determine the period here, which again I have is negative 3. I did a lot of negatives here. I did 1, 2, 3. Jeez. I guess I didn't really notice how many negatives I made. All right, so the period is going to be pi divided by b, which is 3. So my period is now pi over 3. I don't have a phase shift. I don't have a vertical translation. I do have another reflection about the y-axis. Okay. To find the asymptote again, so to find my asymptotes, I'm just going to set what's inside my function equal to one of my new periods, or one of my initial periods, which would be, let's do pi halves. So when I go ahead and divide by 3 on both sides to solve for x, divide by 3 is the same thing as multiplying by the reciprocal. So that would give x is equal to pi over 6. So there's no transformations, but now my new asymptotes is that x equals pi over 6, and then plus my new period, plus pi over 3n. Oh, I forgot to write the domain over here. Let's go and do that real quick. So the domain is going to be all real numbers such that x cannot equal negative 3 pi plus 2 pi n. Now, I could actually simplify that because if you add 1 pi, or not simplify, but you could do it as negative pi plus 2 pi n. Either way, that would work as well. So let's go and look at this. The domain here is going to be all real numbers such that x cannot equal pi over 6 plus pi over 3n. Okay, so let's go ahead and graph this on our initial period. So we have a initial asymptote, or one of our end asymptote is at pi over 6. And since there's no phase shift, then I know it's going to be the exact same on the other side, negative pi over 6. And again, I can verify that because the distance from negative pi over 6 to pi over 6 is pi over 3. So these are going to be our asymptotes. And this does have a reflection. So if here's the graph, our initial period, the reflected graph would look like that. Okay, and again, we're just doing the initial period. All right, last but not least here, I have 2 pi over 3. Again, that's just going to, I didn't really talk about this 1/4, but what that do is that's actually going to be vertically compressing the graph. So let's actually represent that a little bit better, because actually if we have that as a 1/4, it's probably going to vertically compress the graph a little bit farther down. Okay, I'm not very particular. Obviously, what you could do is you could find the x scale and you could actually figure out these points to get some decimal variations. But just as long as you understand that it's a compression and that it's going to be compressed vertically, that's enough for at least my students. Here again, we're going to have another vertical compression because 2/3 is less than 1. So again, my graph is going to be a little bit scrunched vertically. You can see here the phase shift is going to be pi to the right. I don't have a b, so I don't have to go through all that work I did before. And pi to the right, and that's it. So my period is just going to be pi over 1 in this case, and that's it. So let's go ahead and find the asymptotes though. So I'll still set x minus pi. This is for my asymptotes. Set what's inside the function equal to either my start or my end. I'll use the end, and then I'll just add a pi here, add a pi. X is equal to pi halves, change pi to 2 pi over 2, so x is equal to 3 pi over 2. And then again, if I wanted to figure out what's going to happen where the next asymptote is, you're just going to add the period plus n. So add the period n times. So therefore now my domain is going to be all real numbers such that x cannot equal my asymptote plus all the other occurrences of that asymptote. So let's go ahead and graph this. Now again, let's graph the initial, I'm going to graph the initial period on this one. So, that's negative pi halves. And this is positive pi halves. That's the graph, right? That's the initial period. So this graph is the exact same graph. It's just being shifted pi units to the right. So what's happening is if I'm moving everything pi to the right. So if I add pi to negative pi halves, I get pi halves. If I add pi to pi, I'm going to get, or add pi to 0, I'm going to get my new intercept is at pi, and my new vertical asymptote, which is at 3 pi halves, which I kind of already discussed. So it's the exact same graph, just shifted over pi units to the right. Okay, so that's kind of our idea here with our tangent functions, is basically just to make sure that we can understand the differences from the tangent function as well from the sine and cosine functions. Also kind of work into identifying these asymptotes here. And now what we're going to do is just kind of work on some different characteristics that we can identify with our sine, cosine, and tangent graphs.